Hello, everyone. Welcome with STEM and Space for today's very exciting journey of satellites in space. So in a sequence of webinars, we keep bringing very interesting topics where we learn about it and also do some exciting things. So today also, we have very exciting things lined up in the session. So stay with us till the end. And there are two very interesting informations also to be shared today. So to begin with today's topic, that is satellites in space, advantages and issues. You may have a lot of knowledge about it, but it has got its own pros and cons. And today we have the co-founder of STEM&Space, Dr. Mila Mitra with us, and she'll be taking us through the session today. So over to you.
Hello, everyone. Welcome again to today's webinar. I hope you have a lot of fun as you've been having. And today is we are still celebrating World Space Week, although it ended. But today is the last event for World Space Week, and some of you have already joined to celebrate World Space Week with us. So I'm going to be talking today about satellites in space. The theme for World Space Week this time is satellites and sustainability, or space sustainability. So I'm going to talk to you a little bit about that. And I know you all want to ask this question. So yes, we will have Kahoot today at the end of this presentation. Okay, so do listen carefully because we will be having Kahoot today after I talk a little bit to you about this topic. Okay, so World Space Week is October 4th to October 10th every year. It's an international celebration of science and technology, which means that all around the world, people did so many different things to celebrate astronomy and space during the week of 4th to 10th. So this was declared as an international event by the UN General Assembly in 1999. Why October 4th? Because that's the day Sputnik 1 was launched. And why October 10th? That's the signing of the treaty for peaceful use of outer space. So let me talk to you a little bit more about these two events. October 4th, 1957, that's of course a long time back, the Soviet Union launched the world's first artificial satellite, which is Sputnik 1. Sputnik comes from a Russian word that means traveling companion of the world. Remember, it was our companion. It was Earth's companion. Sputnik was only like a small metal ball that weighed 83 kilos. It carried a thermometer and two radio transmitters that transmitted back the basic information to Earth. Now, the last day, why October 10th? It's 1967. That was a decade after the Sputnik launch. So what happened? Some of you might know the history that when USSR or Russia launched Sputnik 1, then US also got on the space race. They also went on to launch several missions, which finally ended in Apollo missions that landed man on the moon. But it was like a space race between USSR and USA, and people were concerned that it may not lead to, military attacks or something through space. Therefore, a treaty was signed where different governments had to sign that space would be used for the peaceful exploration of space. So yes, that's why it's October 4th and 10th. So October 4th, 1957 is when the first satellite was launched into space. And now so many years later, we have, we have so many satellites. Our world is dependent on satellites. Our day-to-day life is dependent. So today I'll talk to you about how we use satellites in our daily life and what is the problem that's going to emerge soon. And that problem is called space sustainability. So let me first tell you about how satellites have improved our lives. What is a satellite? I'm sure most of you know the answer. What is a satellite? It's a small space-based object that moves in an orbit around a larger object. It's gravitationally bound to it. So here we have a picture of the moon. That's also a satellite. We don't usually refer to it as a satellite, but it is. And then there are the artificial satellites, which are intentionally, intentionally placed by scientists and engineers in orbit in outer space. So what do satellites do? So most of you might know some of these answers. So let's take a quick review of what satellites do. Position and navigation, communication, imaging, monitor, and surveying, and science and technology. These are broadly 4 categories. Let me talk to you a bit about each of these categories. So satellites do navigation and positioning. So before I move on and talk more about this, can anyone in chat write what are some obvious usages that use satellite positioning? Do you know some of the applications we use? Can you put it in chat? Okay, so let me start talking about it.
We have one.
GPS. Okay,
Yeah, sorry to
we have an
interrupt.
answer.
Yeah, we have several answers coming, like to travel around Google Maps.
Perfect.
Okay, and somebody's asking meaning of surveying. So if you can just
Okay,
tell.
yeah, I'm going to come to surveying. So
Okay.
yeah, each of these terms I'm going to talk about more. Okay, so I'm talking about the first one, which was navigation and positioning. So let's talk about what that means. Yes, we have GPS, geo positioning systems, which means we can find out our exact location using satellites. You see the picture here? Many of the cars have sat nav, which is satellite navigation. So satellites can get the exact coordinates, and through that, they create Google Maps for us. We get the GPS coordinates, and all the way from how to find our way to a vacation site to how to go to our friend's house. Everything we get the information through satellites, or what is the best route? Is there too much traffic? We get everything. So we get it through satellites. So before satellites did it for us, these are called navigation satellites. Before they did it for us, even I myself have carried paper maps around with me, trying to find different locations in the city. So besides helping us with mapping and traffic, satellites positioning and navigation can also help us track endangered wildlife and also ships and airplanes. So everywhere things can be tracked, and that keeps you on the map. You won't get lost. There's so many ways to track. The second type of satellites that we use all the time are communication satellites. So how do communication satellites work? They're like mirrors. You reflect up and then it reflects down. So it's like a satellite that's a mirror in space. So there's a station that will send an uplink, and then there might be more than one ground station that receives that downlink. Mostly radio waves are used for this. So what kind of things can we get with this kind of satellite? Internet. Look, you're all listening to me right now on the internet. We're going to be we're always communicating. We're sending WhatsApp messages. We are doing virtual meetings and logging into our schools and universities. It's all through the internet. Then communications, information flow. We are all watching streaming shows all the time now, Netflix and Amazon Prime. So everything is through communication satellites. So of course we use it for these really important things of being connected to a network and streaming. But once satellite communication started, it also enabled rural communities and isolated communities to suddenly be connected. Because remember, before that, there were landlines which need a physical system. They need telephone wires and so on. And a lot of times, this was physically not possible to be placed very close to, remote areas or very rural areas. So those kind of localities were not connected at all to the community and to society. But now internet communications have been provided to even rural communities. So you probably don't even think about it, but we use communicating satellites all the time. When you go somewhere, you go to a fast food restaurant and you're ordering something, you probably just give a card. Your parents just, give their credit card or debit card or a Paytm. Then what happens? The signal actually goes to a satellite that sends a signal to your bank, and your bank has to authorize it. All this happens so quickly because of communication satellites. So our world depends on communication satellites. Now, the third kind of satellite I talked about, I've already mentioned positioning and navigation. Second was communication. And then there are satellites that do imaging, monitoring, and surveying. What does that mean? One of you asked, what is survey? So such satellites like this have cameras. These cameras look out and actually take images of the area beneath them. So these cameras can cover wide areas or smaller areas. They also go around so in many orbits. So they can take pictures of all around the Earth. So surveying means taking a picture repeatedly so as to monitor, is something changing? Like, is the coastal line changing? Are the forest levels changing? Is there some change in climate conditions? Even things like, is there a tsunami or a hurricane coming? So these are survey satellites. What do we use such satellites for? Farming, weather forecasts, monitoring such as climate change and natural disasters. Of course, there are many more uses. These are a few of the uses. Let me talk to you a bit more about surveying. Surveying means that you keep on taking measurements of certain kind of parameters, such as for weather, you take temperature, precipitation, clouds, and wind direction. And through repeated measurements, you can tell how the weather might be in the next few days. You can predict it by modeling. So you might say, okay, there's too much precipitation, there's the wind direction is changing, so there will be a cyclonic winds that will come in this direction. So weather forecasts have got better and better because our measurements of surveying are so much better now because of these satellites. So not just weather, there's also climate change monitoring. Now, what's the difference between weather and climate? Weather is at a local level, like what is the weather like today, tomorrow, or maybe next week. Climate is the same survey over decades, over many years. And that's when you get the information that something is changing long term, not at a daily level, but long term. So you say, okay, the coastal area in this region seems to be disappearing because there's too much water. The sea level has risen. So, or you can say, even about weather, you can say that it's got hotter and hotter in Delhi, and the monsoon season seems to be for a very short time now. So, climate change talks about longer term changes. So, even for climate change, these survey satellites monitor our atmosphere, sea levels, polar ice caps, and so on. And again, they model them together to come out with changes that may be happening. So here are some specific uses of this kind of survey satellites. Many of these are called Earth observing satellites. They observe the land and take images. So one of the big problems, like you see in the picture here, is that I don't know who of you know a term called Nutella. Okay, Nutella is like a chocolate sauce, and this is coffee. Okay, so why have I marked them? So I don't know if you know, but these are going to be a problem in the future. That's it's pretty sad for people like me who love coffee, but coffee might be a scarce commodity in coming years. And why is that? Did you know that? Why is that? It's because both Nutella and coffee depend on palm oil. Palm oil is a kind of forest, and these forests are being cut down because many food items need palm oil. So now Earth observation satellites can indicate where there is deforestation occurring and try to catch those situations. So they can be dealt with. So these are ways that Earth observing satellites can be used. Here's another example. So what did you eat for breakfast this morning? Did you eat cereal? Did you eat bread? So yes, Earth imaging satellites or Earth survey satellites also help farmers. They help them get a broad idea of how the land is changing, how the weather is affecting their lands. Is their land ready for harvesting? So it gives the farmer a much broader eye view of their land. If they walked around or went around on their tractors, they would get a very small view, but this gives them an overall view and helps them make decisions. Okay, so the fourth type of satellite I mentioned are the ones that do the science and technology. So some of these satellites actually measure, there are satellites that are measuring and trying to take observations in space. There are satellites that use for technology testing, like instrumentation, cameras, radar. These are tested because space, of course, is it's a good place to test technology before you send it out further, much further into space. Okay, so I'll talk about, you know, ISRO has been very successful in the kinds of satellites they have sent. I'll talk about one specific satellite system that ISRO has. It's called the IRNSS. That's the Indian Regional Navigation Satellite System. So it's also another word for it is NAVIC. NAVIC stands for Navigation with Indian Constellation. So constellation here is not sky star constellations that you've heard of, but constellation is also a term used for a large group of satellites. So in this case, NAVIC has 7 satellites, which are geostationary and geosynchronous. I'll just come back to these two terms again just a little bit later. Now, interestingly, Navik also is a Hindi or Sanskrit word meaning somebody who's a navigator or somebody who takes a now, a boat, and steers a boat. So it's a very interesting, nice name. And this is our own navigation system. It covers all of India and 1500 kilometers beyond India. So it's very important for us, even from military surveying point of view. Okay, so this is a interesting shot of how the IRNSS satellites go around in orbit. They're all tilted at different heights. Okay, so now I just talked so much about satellites. 4 types of advantages that we use. Again, communications, navigation and positioning, survey, and science and technology. And now you know that we cannot live without satellites. We use it for the internet, we use it for streaming, we use it for positioning and mapping. And of course, our scientists use it for so many more purposes. So that means we need better and more satellites. We need better bandwidth, better broadband connections. How do we get it? We have to put more satellites in space. But that is going to lead to a problem, the same problem that we are already facing for our other natural resources, like oceans, like our forests, like our atmosphere. Soon space will also get crowded. And once it gets crowded, there may be many accidents or many problems. So this concept is called space sustainability. Means we have to figure out a balance between what we need and what will help us versus how we can preserve space as a natural resource for the next generation. Okay, so space sustainability aims to maintain the safety and health of the space environment. So we have to meet our current needs without compromising the future needs. Now we have to start thinking of space. And when I mean space, we all know that space is infinite. I'm not talking about infinite space. I'm just talking about low Earth orbit, which is the space directly above us, directly above our atmosphere. So this is what we need to protect because space as a resource is also as important to us as our other natural resources. So space sustainability as a problem focuses on low Earth orbit and geostationary orbit. And why these orbits? I'll just come to that. It's because these orbits have limited space. Okay, so let's talk a bit. We won't talk much about this, but let me just mention a bit about three types of orbits. The first one is geostationary orbit. In short, it's called GEO. GEO is one of the highest orbits, very high up. It's 36,000 kilometers. So what happens for satellites in this orbit? They're very high up. They are always exactly placed above the equator, and they take 24 hours to go around. That's the same rotation or time that our Earth takes, which means that any satellite placed in this orbit always sees the same location on Earth. That's why it's called geostationary orbit. So which kind of satellites can be placed here? Satellites such as weather satellites, because they can keep on looking at certain areas and see how the weather changes. They're also telecommunication, because there might be satellites that there might be antennae or ground stations on Earth that can be tilted to face a certain satellite, and that station does not have to be changed. It can keep on communicating with that satellite. Okay, so geostationary orbit, any satellites can see a large area, and therefore very few satellites are needed here. In fact, 3 satellites placed here can cover the whole Earth. They can get a glimpse of the whole Earth. Now, the opposite of this is LEO, low Earth orbit. This is very close to our atmosphere. It's only at just above. It's only about 1,000 kilometers. So low Earth orbit, and they can be placed at any tilt. They don't have to have the same tilt as our equator, which means that you can place, there are many available orbits for you to place the satellites. And which means, yeah, so there are many available orbits, which means you're already looking for crowding. And the other problem is that because they're so close to Earth, it's the same as if you take a camera and go very close to a person, you can only get a zoomed in picture of them. So this is a really good orbit for imaging satellites because they can zoom in and get high resolution pictures of the Earth. The problem is they can see only very small parts of the Earth. So because they're so close to Earth, so you need many satellites to cover the Earth. And so you need constellations of satellites to create a network. And this is where the problem of low Earth orbit comes in, because you need many satellites to cover the Earth. And you also have available many tilts, many orbits, because you can be at any tilt. The other issue is that for low Earth orbit, it's very close to Earth. It's the closest you can get. So even ISS, International Space Station, is placed on the low Earth orbit because it's easily manageable from Earth to go to that satellite and work on it, help it, send it provisions, change the astronauts who live there. So all that can be managed because it's so close. If you're further off, then it would take a lot of time to reach you, and therefore satellites like ISS that are space labs where astronauts come and go. They are at low Earth orbit. So low Earth orbit, and then there is one in between called medium Earth orbit, MEO, which again can have several tilts. It is between LEO and GEO, and it's usually the navigation satellites. Okay, so again, here is just a brief glimpse of what I said. There is the low Earth orbit, which can be at different tilts, and there are many satellites in low Earth orbit. There are fewer satellites in middle Earth orbit, MEO, and there are very few satellites in GEO because it's much higher. Now, LEO, the problem, like I said, is you need many satellites to cover it. And also, each of them takes about 90 minutes to complete one orbit. Okay, so looking at the picture on the left, LEO, MEO, and GEO, what is the red part? The red part is debris. I'll just come to what is debris, but just look how many more satellites are in LEO compared to MEO and GEO. Okay, so this is the challenge to space sustainability. We now have what is called space junk. So what is space junk? Space junk is defunct satellites, which means, when we send satellites into space, then they have a limited lifetime, just like our automobiles and our airplanes do, but satellites more specifically because they are given enough fuel to last for a certain number of years, maybe 10 years. What happens after that? They're still in space. So many of them are still in space, although they're not working. So those are called defunct satellites, dead satellites. There are also rocket bodies, parts of rocket bodies. So that is called space junk. The other word is space debris. So this creates orbital crowding. It's just like a traffic jam. There are too many satellites. That's called physical crowding. And there can even be collisions then. There's a third problem to space sustainability, which is space security, because we want to make sure that any country is not deliberately coming and trying to sabotage a specific satellite. So space sustainability means we have to worry about all these defunct satellites and rocket bodies and even small parts, all the way to small parts of specks of paint that are floating around. Let's take a quick look at how satellites increased from the 1960s to the 2000s. See how many more satellites there are. I mean, it seems impossible that a satellite could go around and not be hit, right? So that is the problem. So where does all the space junk come from? Why is it dangerous? And are we doing anything about it? So let me come back to satellites versus debris. So NASA is monitoring debris. Now the question again becomes just like asteroids, that we can monitor debris parts, but what can we do about it? These are two different problems. So they are being monitored. There are whole satellite debris programs nowadays. And for any of you looking to go into new kind of careers in space sciences, satellite debris is going to be one that is a good field to go into. Okay, so NASA monitors 26,000 debris objects. And now if you look from the left-hand side in this figure, so there are discarded rocket stages. So starting from here, there are discarded rocket stages. Then there are defunct satellites, which are the satellites that are dead. There are unidentified debris. And then as you get into the red zone, there's such small fragments that they can no longer even be identified by NASA or by the tracking systems. They only have to be guessed at or modeled. But the problem is that even the smallest fragments at that speed could cause a lot of damage to an active satellite. So we have to be careful about that. Okay, so here's some numbers. We've been sending satellites for over 60 years. we've sent more than 11,000 satellites to Earth's orbit. Of these, only 3,300 are active. So there are about 8,000 that are not active. Besides that, there are millions of objects, all the way from inactive satellites to flakes of paints that are going around and floating in orbit. Okay, so now this is the big problem. We've sent over 11,000 satellites. 1,280 satellites were launched in 2020 alone. Out of these, only 3,372 satellites are currently active. Okay, so have there already been any disasters? I mean, looking at this, it makes my head spin because it looks like any minute there's going to be a disaster. So there have just been a few collision-related problems. The first documented collision was in 1996 when a French satellite was struck by rocket parts which had exploded earlier. In 2009, a US commercial satellite, and there are many of those called Iridium satellites, it collided with an inactive Russian satellite called Cosmos 2251. And the collision itself created 2,600 pieces or 2,300 pieces. Sorry, I've written it wrong. And this creates a bigger problem. It's called the Kessler effect. It means that every time you're creating small pieces, each piece now is available to collide with so many more parts. So this creates like a chain effect, and then a possibility of collision increases. In 2016, a window of EarthCam, in fact, was damaged by just a paint fragment. So that's pretty scary, right? So what is being done about it? So before we get there, here's more scary facts. As you might know, SpaceX has already sent a constellation of satellites called Starlink, and it will be sending many more of those. Many of these are being sent to make internet connections better in that country, broadband connections better. So that is the objective. So SpaceX has been widely criticized by astronomers because you see, like in the picture above, you see multiple, a train of satellites, as it's called, like that, and it really disturbs the view for astronomers. Now, Amazon's Project Kuiper has been approved, and it will also be sending 3,200 satellites. UK has OneWeb, China's Hongyan, and Canada's Telesat. So the problem is that we always want more and more connectivity, and that's why there are so many more satellites going to be placed into space. But yes, that will create the problem also that we need to be aware of. Okay, so what are the potential solutions? If you look at the right, UNOOSA, that's United Nations Office for Outer Space Affairs, are the ones that most worry about this. And they have two measures that are in space. Again, it's UNOOSA, UNOSA, and you'll be seeing that name all over the place now that I've mentioned it. So there are two ways this is being dealt with. One is technical measures, like how to remove the space debris, how to manage the orbital traffic, and how to improve the awareness that there is a problem. So there is also policy measures. So there are space laws and space governance, which countries have to sign, saying how many satellites they would release, where can it go over, and so on. So both of these are ongoing, and hopefully they will help. So can we stop this kind of orbital junk reactions? So there are there are tests that have been done. So one way is that drag part of space debris down into the Earth's atmosphere, and like small meteorites, they may be burnt away. In 2018, a satellite called Remove Debris was able to successfully deploy a net around a dummy satellite and bring it in. ESA has awarded a contract to clear space to retrieve a specific rocket debris. How will it do it? with robotic arms, 4 robotic arms that will actually pull it. So yes, there are things, technology that's being tested. However, these methods are only for larger pieces of junk because you can only pull pieces of junk or put a net around larger pieces. You can't do it around small fragments. So with this, there are some ways that we can think of to decrease these numbers, huge numbers of satellites. Here's a fun cartoon that will again help you revise some of them. Okay, the first way is reduce the number of satellites at end of life. So if there's a way that when the satellite's fuel ends, there is a way to take it away, then that would help either by some kind of destruction system or by bringing them back to Earth. So there's a concept called graveyard orbit, which is increase the size of a satellite to beyond GEO. Because as I said, there are very few satellites in GEO, so that decreases the crowding in LEO. The third way is deorbit or make it go down to Earth's atmosphere where it may burn up. So I hope you got an idea today about satellites, how they are so useful to us in our daily lives, and how they're also creating a problem for us because of overcrowding, and what we might be able to do in the future to help this. So unlike all the other environmental factors, you cannot do much about it as students, but you can be aware of it, and maybe some of you can get into this kind of technology. Okay, so thank you, and keep exploring space with us. So with that, we have two very important announcements. So yeah, I hope you all enjoyed World Space Week. I hope you all were able to do different things in astronomy. And today, I'm going to now make a couple of important announcements. And then what you've been waiting for, Kahoot, is yes, it's going to be coming up soon. Okay, so I want to share that again this year we have launched National Astronomy Challenge, which is the biggest astronomy Olympiad. It's been going on for the past few years, and every year, many students register and they go through different learning experiences, many webinars, skill building sessions, and eventually they get to take an Olympiad. So let's. I hope you all register and join us for that. And with that, I'm going to turn it over to Aryan sir, who's going to tell you a little bit more about that.
So thank you so much, Mila ma'am. That was a wonderful session. People do know about satellites' importance, but about space debris and how to use it wisely is another thing. So that was a wonderful session. I hope it enlightened each one of us. And yep, I'm going to talk about two very important things, and then we are going straight to Kahoot. I know many of you are waiting. So just before that, let me share my screen and talk about a few things. So number one, students, those who are new with STEM&Space right now, this may be a very new information for you, definitely. Those who are old can also understand this. National Astronomy Challenge is on. National Astronomy Challenge, how can you know what is it all about? You can just go on browser, any browser, and type in nationalastronomy.org. That's it will lead you to the website of National Astronomy Challenge. It's basically an Olympiad where a lot of participants have been actively participating from India, UAE, and the registrations are on now. So anyone interested to participate in this Olympiad can register. How to register? Just go to the website that I just said, that's nationalastronomy.org, and there under register now, you will actually get two options under register now. One is individual registration, one is school registration. So you as an individual can also register for this very competition, this challenge, or you can also register from the school's end. Okay, so all you have to do is just click on it, like I'm clicking on individual registration, and it talks about all the details that you need to fill in and make the payment and be a National Astronomy Challenge participants. They have been, you can check on the registration process also if you have any problem. We provide the study materials for this what content can come in the challenge. So you have to go through that study material and also improvise a bit of your understanding, because questions may be just based on study materials. There have been a lot of winners from the past, so I would also like to show you that, like the previous year winners, like 2019 winners were felicitated at the Dubai. Okay, and then there have been recent winners from 2020 and 2021. They were taken to Vikram Sarabhai Space Center, and this time for this National Astronomy Challenge competition, the winners will be taken to Aries Observatory. Okay, so that's an interesting opportunity where you will be awarded, and also it kind of builds a good temperament where you are around the people who love the same thing, you interact the same things. And then definitely it's an observatory, so you're going to have a lot of fun where there will be a large telescope for sure. Okay, so this is National Astronomy Challenge. Those who are interested can visit nationalastronomy.org. Another interesting platform that we have is Cosmic Kids Club. So I'll just tell you where you can go. Okay, so Cosmic Kids Club is another platform where you can have a lot of fun and bring up understanding about space. So we basically tried on this very platform, we have tried to bring you things in a more gamified way, in a very interesting way. So you can go to app.cosmickids.club. This is the URL that you can type in. Okay, and let me just sign in also to show you. So there we have a lot of videos and also comics. It is for every age group, actually. Any age group can come and understand things, whatever they want to learn. So once again, on this platform, people from all different age groups will be here, and everyone who is interested in this very thing will be here. That's one more plus point. So this will bring up that temperament if you're interested in the field. All the live sessions that we do, like this is the live session going on right now. So from now on, these sessions will be done from this platform only. So make sure you have noted down this URL, app.cosmickids.club, so that you can join with us on the live sessions. You can check out all the videos on very interesting topics. The comics you can see on your own, what you like, you can see them. This is credit based. There is a section for TV where you will be able to see all the videos. Okay, and also you can check for what's up in the sky for a particular month. So every month this is updated and you can plan your own observations after watching these videos. There is a read section where you can enjoy reading if you love reading and you're interested in this field. This is the place for you. And I was talking about NSE content. So NSE, the National Astronomy Challenge, it is for different age groups, right? So you can access the content also from this very URL itself. Okay, app.cosmickids.club. And also there is a leaderboard. It will soon be improvised further. So on leaderboard, whoever reads as much material, after every video or comic, there will be questions asked. You have to answer those questions, and that way you earn points. Soon we will be having challenges also on this very platform, and we will have a reward store also coming soon. So those rewards that you will collect, the points that you are collecting, can be turned into actual gift. Okay, so wait, what kind of gift can you gain from those kind of points? Now it's time to start our Kahoot. So those who are new on the Kahoot platform, let me first tell you how to join in. You can go to browser and you have to type kahoot.it. Okay, just open the browser, type kahoot.it. Make sure it is .it and not .com, and enter. As soon as you do, a page will open which will ask you for the game pin. Okay, I am going to give you the game pin in a minute. You have to enter the game pin, then click on enter. It will ask for your name. Enter your name over there, or your professional names, and then you can click on OK Go, and the game will start. Now, let me just initiate the game so that I can share the game pin with you all. So just give me like 20 seconds, maybe. Those who have to join the game, quickly go to kahoot.it, and I'm sharing the game pin now. All right, the game pin is here, guys. Please join in. It is 4369559. There is no gap over here. You have to write in continuation. Those who already know about the game, you are aware. Those who don't know, you have to type in the game pin continuously. There is no gap over here. Once you enter, your names will appear on the screen. Like I can see many of you are here. Tejas is here, Rashmi is here, Arav. Okay, so your names will start appearing on the screen. You can actually watch on the screen if you have joined. Hurry up, everyone. 45 participants are in, and as I'm speaking, many are coming in. If anyone has got any problem in joining, you can write it in the chat. All you have to do is you have to go to the website kahoot.it. You see it is written over here also. I'm highlighting it. It's www.kahoot.it. Just enter this in the URL. Open any browser, type this in. It will ask for game pin. Enter the game pin. It is 4369559. Hurry up, guys. I'll scroll up and down so that you can see your names over here. You can keep on checking. Once you have entered, it will say you are in on your screens. 81 players are in. Keep coming. Hurry up, quick. Others are waiting. Meanwhile, I'm just explaining you for how to play the game if anyone has not played it before. So it's just like any general quiz. A question will appear along with 4 options. Whichever option you think is correct, just click on it. Okay. But there is one trick. It is actually time dependent. You will have limited time, like 20 seconds to answer a question. So make sure you are clicking the answer within the time. Otherwise, your answer will not be submitted. After every question, there will be a leaderboard. So whoever answers first will get maximum points. So not just you have to answer, you will also have to be quick so that you can get maximum points. Okay. And anyone who maintains a good answer streak, like you are answering back to back correctly, you will get more points for that also. So 102 participants are in right now. Anyone who wants to join, I'm giving you 2 more minutes. Hurry up, not more than that. Please join in quickly. The website to join is www.kahoot.it. Okay. And then you enter the game pin, that is 4369559. And after that, enter your name and you will be in the game. 1 more minute, everyone. Hurry up. I'm just giving 1 last minute. (102 participants so far. 103 now. 104. Okay, it keeps on increasing as I'm speaking. All right, on the countdown, I'm going to start now. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Here we go, everyone. Eyes on the screen. Make all the best to everyone.
Aryan, can you just scroll down once because everybody wants to see that their name is there.
Oh, I just started.
Okay, that's okay. Go ahead.
After this question, I'll take a pause. Okay.
Right.
All right. So the first question is up. What is space junk? And your options are food, dead satellites, rocks, asteroids. What is space junk? Hurry up, time's ticking. 4, 3, 2, 1, and 0. Okay, now you can't answer. As I said there is a time limit, so make sure you answer within the time limit. Anyone who still thinks have not joined, the game pin is on the screen itself. It's 4369559. 4369559. It's right here at the corner. 4369559. Okay, you can join in still. So in this question, 95 of you answered it correctly. Very good. Majority wins. Wonderful job, guys. So some of you answered it incorrectly. We are talking about space junk. So it is created by the satellites, okay, which satellites which are no longer functional, and they even, collide and create even more debris. So that is what is space junk that we are talking about here. Okay, let's see the scoreboard. How does it look now? Wonderful. Ritvik on the top, followed by Anshul, Dishita, uh, Radha Krishnan, and Aditya. So guys, you will have to be, very, very fast in the next question. The reason I'm saying is, you see the last three have got the same scores, and even the top two, just two points difference is there. So make sure you answer it correctly. Okay, here we go. All the best to each one of you. Choose the wrong option. Satellites provide us with dash, energy, internet, communication, weather forecasting. You have to choose the wrong option. Okay, time's up. So 91 of you said energy, and yes, this is the right answer. Satellites provide us with internet, communication, as well as weather forecasting. Yeah. The precision in weather forecasting has actually come with the help of satellites. So energy here is the wrong option. Well done. Let's see the scoreboard with this question. Okay, it just flipped, guys. Anshul is on the top, followed by Ritvik, Dishita, Pratik, a new entry, and followed by Arav. Up to 27 places. Pranav is the highest climber. Way to go, Pranav. All the best, everyone. Here comes the next question. World Space Week is celebrated starting October 4th to remember the launch of Dash. Fill in the blanks. Sputnik, Apollo, Mars Orbiter Mission, or Voyager. I'm repeating the question. World Space Week is celebrated starting October 4th to remember the launch of Dash. Oh wow, very good. 83 of you are correct. We are celebrating World Space Week today, right? And it is celebrated starting from 4th of October to remember the launch of Sputnik. Remember, Sputnik is the first satellite, okay, by Soviet Unions. It was the first satellite launched up in space. That's how our capabilities increased after that. So we are celebrating Sputnik, launch of Sputnik. Okay, let's see the scoreboard. Okay, just a flip over here on the 5th position. Advika has entered. And once again, be very careful. The points are too close. Like here is equal. Okay. Anshika is the highest climber. Way to go. Let's see the next question. What is Starlink? Is it a spaceship, internet technology, communication satellite, or satellite constellation? All right, 13 of you say it's a spaceship. No. Some of you say internet technology. Indirectly, yes. 13 of you say communication satellite. Once again, wrong. So 60 of you are correct for this question. For those who have not understood, make sure you are learning also, because Kahoot is fun way of learning. Okay, so Starlink is basically a satellite constellation. Constellation, what does it mean? Too many stars come together to form a pattern. So here, so many satellites are there, like a satellite constellation, and this is actually by SpaceX. It is helping, in providing internet access to over like more than 40 countries. We have like 12,000 satellites planned under this satellite constellation, and there will be more in the future. So let's see how it goes, but also we need to use it wisely, as there should be less space debris. Okay, let's see the scoreboard with this question. Anshul is glued to the top position right now, followed by Ritvik. Mahi mystery is a new entry. Okay, that's a mystery. So Pratik and Daphne is in the number 5th position. 7 players have reached an answer streak of 3. That's a good thing. That means you have understood the concept. Here we go with the next question. This is for double points, so make sure you make no mistake, otherwise you will go very down in the scoreboard. ISS is located at dash orbit. The International Space Station is located in which orbit? Is it geosynchronous orbit, middle Earth orbit, low Earth orbit, or geostationary orbit? The International Space Station is located in which orbit? Time's up. I have got the percentage of answer is decreasing now. 52 of you got it correct. So if you are not aware, let me tell you, International Space Station, the largest satellite where astronauts do a regular visit. Okay, it's actually a space lab. It is located in the low Earth orbit. That's how it provides an easy access, for the astronauts to go and come. So make sure you remember now it's in the low Earth orbit. The scoreboard looks like this. Okay, now Mahi has climbed up. Anshul still maintaining the position. Mahi at second with Pratik, Dishita, Ritvik. This was a tough round. No issues. You learned something if you didn't know. For anyone who is still facing issue, like in chat, I saw somebody wrote, still not joined. You have to go to, just open the URL, write www.kahoot.it, and then enter the game pin. Game pin is right here on my screen also. 4369559. Okay, this is internet dependent game, so just in case anyone gets logged out, don't worry at all.
So I don't know if people can enter when you've already started and come halfway.
Yeah, they
Maybe
can
that's
enter.
a problem. They
can enter midway also. That's fine.
Okay,
Okay.
so some of them are having a problem, but I don't know.
It is internet dependent, guys. So sometimes it can happen that you are facing issue because of bandwidth, or there are so many people already, so it can log you out also sometimes. So you can keep trying. Otherwise, there is chat as an option. Here we go for the next question. All the best, everyone. Eyes on the screen. We have already reached midway of our Kahoot quiz. Question number 6 for double points again. Okay. ISRO's IRNSS is dash type of satellite. You have to fill in the blanks. The IRNSS is what kind of satellite? Is it a communication satellite, navigation satellite, survey satellite, or scientific satellite? Okay, so 59 of you got it correct. Those who have answered incorrect, now please pay attention. IRNSS is actually Indian Regional Navigational Satellite System. So if you remember the full form, you have got the answer. It is actually by Indian Space Research Organization that provides a good GPS system for India itself. Okay, the navigation systems that we use on mobile phone, Google Maps and all. So IRNSS has actually improved that GPS system in India. All right, so here has been a bit of switch. On third position is Dishita, followed by Aryan. Okay, somebody is playing with my name. Followed by Daphne. Sorrow has the highest answer streak. Well done. Let's see the next question, guys. The word Sputnik means. What does the word Sputnik means? A blazing star, space, exploration, or traveling companion? The word Sputnik means. All right, 68 of you got it correct. It means traveling companion. The word Sputnik, the first satellite, it was actually picked, very wisely. It means traveling companion. It's a traveling companion of space. And the scoreboard looks like this. Now everybody is glued to their position. 13 players have reached an answer streak of 3. That's good to see, actually. Let's see the next question. This technology helps us in correctly locating a specific address. Which technology are we talking about here? GPS, GNS, LPS, MPS. Which technology helps us in correctly locating a specific address? I think the image just revealed the answer. All right, so well done. 106 of you got it correctly. It's GPS, the global positioning system. That is what we use in our phones also. That guides us even through the narrow streets. Sometimes can get us stuck also. Yep. Okay, so let's see the scoreboard. Okay, Daphne and Aryan just switched places. Meanwhile, Dishita is on fire right now, has got the highest answer streak. And what to say about Anshul and Mahi? They are just at their places. Let's go to the question number 9. And this is for double points. So make sure you make no mistake. Which kind of Earth orbit needs to worry most about too much traffic and collisions? Okay, middle Earth orbit, low Earth orbit, high Earth orbit, polar orbit. Which orbit has got the maximum traffic of satellites where maximum collisions can happen? What do you think? Which orbit is it? Okay, so 21 of you said middle Earth orbit and 72 of you said the low Earth orbit. And the rest of the options are, except for blue, all the options are incorrect. Low Earth orbit is the right answer. As during explanation, we heard low Earth orbit is very close to Earth. It's like over here, you see, when you go at a height of 200 to 2000 kilometers, that's the range of low Earth orbit. So in that orbit, you can place the satellites at any angle. So maximum satellites are actually in this low Earth orbit. That's where, maximum space debris is there, and also collisions can happen. So this is the orbit that we need to worry about. Okay, no changes over here. Meanwhile, Kian is back with an answer streak of 3. Well done, Kian. Moving to the last question for today. Point out the one that does not pose a challenge to space sustainability. Space debris, orbital crowding, space security, running out of fuel. Which option does not pose a challenge to space sustainability? Hurry up, time's ticking. There is no negative marking, submit something, okay? All right, so good that many of you answered. The correct answer is running out of fuel. The, running out of fuel does not pose a challenge. You see, 3 challenges were talked about. One is space debris. If there is too much space debris, that is definitely a challenge. Orbital crowding, a lot of space junk. Space security, we need to make sure that the satellites are not being used for wrong purposes. Okay, so these are the main things. Let's see the final podium. Congratulations, Daphne, Deshita. And in the spotlight, we have Anshul. Congratulations. All of you have got 10 out of 10. That's wonderful. Runner-ups are Aryan and Mahi. Congratulations. Congratulations to each one of you. Wonderfully played, guys. So with this, we have come to end of our today's session. I hope you enjoyed. Once again, I'm just reminding you all can register for the National Astronomy Challenge. It is already on. So make sure the interested people join. Those who are not interested can also give it a try. And then we have the Cosmic Kids Club platform where you can join in and learn and explore more. I hope you enjoyed. Thank you so much, guys. With this, we will sign off. Mila ma'am, do you have anything to add over here?
Yeah, thank you everyone for joining in. And with that, we are ending our World Space Week. And I hope you enjoyed our presentation today and you learned something about space debris and how to sustain satellites in space. So thank you all for joining. Again, looks like you enjoyed the Kahoot. So we'll see you again shortly. In fact, next week, we have a webinar on solar eclipse, because as you might know, a partial solar eclipse is going to be visible from India on October 25th. So we will have a webinar on that, but that will be on the Cosmic Kids Club platform that Aryan sir just showed you. So please join us there and have a good evening, everyone.
Yep. So all the best, everyone. Keep exploring, keep learning. Bye-bye.